In this video we'll start to take a look at the code in the run stage. So we start with create buffers. We're just going to create the vertex and the index buffer in this video. So here's the create buffers function, and it's a member of the mesh type. And creating a buffer is a two-step thing. We describe the buffer and then we ask the D3D device to actually create the buffer resource on its end. So let's talk about describing the buffer first, and this is the vertex buffer to begin with. And first thing we need to do is to calculate the number of bytes in the buffer in total, which is the size in bytes of one vertex multiplied by the number of vertices that we're providing. So how big is a vertex type in this case? Well, in the previous video we showed the input layout description, which is this: position, normal, color. Each one of those is a RGB32. So that's for 36 bytes in total. But this is the shape of vertex that the GPU sees, and then internal to the app, this is the type, of course, of vertex that we're using, and these are the data members of that type. So again, it's the same size and shape, the same data, 36 bytes. So we take the size in bytes of a single vertex, multiply it by the number of elements in this vector. Let's drill into that data member. So that's actually a member of the same type that implements create buffer. It's our mesh type. It's just a standard vector of those vertex types. And in the previous video, when we were calling add position and color, the implementation of that was actually going in and creating vertices of this type and adding them into that vector. So if we're rendering a triangle, this vector would have 3 elements in it. Each one of them would be 36 bytes in size. We're also describing this as a vertex buffer. I won't cover that field. That's to do with whether the GPU or the CPU can read or write the buffer. We'll talk about details like that in a later playlist. But then we have a sub-resource data structure, and we set its data member to the address of the first vertex in the vector. So now we've defined the buffer, we've defined how big it is in bytes, and we've pointed at the beginning of the buffer. Now we're ready to ask the D3D device to create a buffer on its end, passing those descriptions, and we get back a smart pointer to what it created. So that's all we're doing here. We're not attaching it to the rendering pipeline yet. This is similar to what we were doing in the last video with input layout and shaders. We were just getting smart pointers back from the device for those. We hadn't attached them to the pipeline yet. We'll do that. We'll show that in the next video. So that's the index. That's the vertex buffer. Now we'll do the index buffer, which, as you can see, the structure of the code follows the same pattern. The difference is the size of each element in this buffer. Instead of figuring out the size of a vertex, this time we're figuring out the size of an index and multiplying that by the number of indices. Again, for a triangle, that'll be 3. But how big is the index type? Well, that really depends on how many vertices you want. I've got it currently set, the index type is currently set to a 16-bit, unsigned 16-bit value. So the maximum value I can store in there is over 65,000. So that means that I can't have any more than 65,500 vertices in the vertex buffer, which is fine for this simple app. If I want more than that, then I can just recompile and use a larger index type. So that's just 2 bytes per index, multiplied by, if it's a triangle, the 3 indices in there, or 4 if it's a square and using triangle strip. This time, say it's an index buffer, and set up the pointer to the first element, and then again, same pattern, just calling create buffer. This time it's described as an index buffer, so the device will know what to do with it. So in the next video we'll go into the update and render loop.